Academia is more than research output and publications. In this seminar series, we discuss the personal and social aspects of academic work that are not discussed enough. Welcome to Life in Academia.
Finally, let's start this. A very, very warm welcome to our speaker today, Bernd Stahl from the School of Computing Science at the University of Nottingham. Bernd is a professor of critical research and technology, and he is interested in philosophical issues arising from the intersection of business, technology, and information. And today, Bernd will talk about ethical issues that exist in computing science and hopefully debunk the idea of technology's neutrality. Technology is not neutral because we perfectly imperfect humans created and incorporating our strengths and flaws into this delicious and confusing mochi ball that is the ICT sector. So this talk will cover how technology has a broader societal impact, including things such as the future of work, changing the nature of warfare, economic, political power distributions, and environmental impact of computing. But most importantly, Bernd will tell us of reflexivity and how we can use reflexivity as a tool, not only to make the outcome of our work, of us computer science programmers, researchers, designers, how to make our work more ethical, desirable, and sustainable, but also hopefully the process towards the output more better. So I am incredibly happy that he's our first speaker in the second season, and I cannot imagine anybody else or any other topic kicking us off other than Bernd and ethics and reflexivity. I will shut up now. Nobody joined to hear me be overly excited about philosophy and ethics. Please join me in welcoming Bernd Stahl.
Thank you very much, Gerzel. That was a very enthusiastic introduction, maybe the most enthusiastic I've ever had. And I hope I'll be able to live up to the expectations here. Listening to you, I just had some ideas of what I could do different in my presentation, but I can't change it now, so I'll just run through it. So I will talk about ethics and reflexivity to warm up, just to see whether people are alive. Does anybody want to suggest what ethics might mean? Give me a definition or an example.
Doing the right thing.
Doing the right thing. Somebody of the non-visible people with the microphone off. Any suggestions?
Not doing the wrong things.
Okay. Turning it around from positive to negative. Any other suggestions?
Maybe it has something to do with moral. So being moral and morality also.
I could now be mean and ask you, what do you mean by morality?
That's up to you.
Okay. Any other suggestions? Oh yeah, we can also do the chat, even though that confuses the hell out of me. Acting according to specific values, right? There we have another concept, values. I could again be mean and ask, what do we mean by that? All right. Oh no, that was just the code of conduct that came in here. I thought that somebody had a very elaborate response to the question, what's ethics? Right, I will now, if I manage to do this, share my screen and talk you through my slides. I hope this is the right one. And I turn on the slideshow. Can you see the slides? Okay. Right. So what is ethics? First question. This is my attempt to give a response to this question. It's about 10 years old at this point, the reference at the bottom. What I've tried to do here is distinguish between different meanings of the concept of ethics. And what you see at the very bottom is what I call moral intuition. So this is about doing something or interpreting something as being right or wrong, good or bad, appropriate, inappropriate. So this is something that we do all the time. in the vast majority of cases, whenever we take an action, make a decision, interact with other people, we do this on the basis that we know what's right and wrong, right? And that's not just ethics, but that's also ethics. However, that doesn't always work. On occasion, this breaks down and we don't know what's right and wrong. And then we come to what I've called here the explicit morality stage, which is more of a, rather than intuition, it is explicit knowledge. So you've thought about it. No, it's always right to do this, or it's never right to do this, or you should not beat children or push old grannies in front of the traffic, or no, those things are wrong, and you can formulate that, right? But even that breaks down on occasion when we don't agree on what's right and wrong. And in computing, a classical example of that would be treating intellectual property. Should information be free? Should it not be free? Should it be protected? There's no agreement on what's right and wrong there, and hasn't been for decades, if ever. And that's where we come into questions like ethical theory. So something is right because of X, and then there are various loads of theories, from it's right because it's your duty, it's right because it has good consequences, it's right because it reflects on your character. And that's what we call ethical theories. And then on top of that, we have what I've called here reflection and meta-ethics. So you think about how you think about what you think is right and wrong. So and this is just an attempt to show the complexity of the concept of ethics. So it has various interlinking related facets to it, but these are not the same. In fact, they are fundamentally substantially different, which is a problem when you want to do ethics from an academic perspective, but also from a practical perspective. So why is this something that you should think about as a computing person, as a computer scientist, as an engineer? So as Gödel suggested earlier, the technology is not neutral, and I would tend to agree with that. And I would assume that the vast majority of technologists understand that and know that as well. But why in particular is computing of interest? So why would you think about ethical issues in computing? Oh, I just noticed I put a question mark in the wrong place. This is an attempt to come up with some characteristics of information technology that are specifically relevant with regards to ethics and that raise concerns and questions. And none of these are completely unique to IT, but collectively they mean that there are a set of issues that are different, for example, between a computer scientist's concerns and those of a, let's say, a civil engineer or a biologist, right? There may be some overlap, but this is a typical set of characteristics of IT. So one is that it just goes very fast. From the initial development, when you build an app, it goes viral, and in 2 weeks it's used by 1 billion people. Now that's something that simply doesn't happen if you build a bridge. Then there is the ubiquity and pervasiveness. You have IT everywhere and anywhere. Now, the fact that we just communicate through IT is an example. We all carry our mobile phones. We all are connected in all sorts of ways, and that is pretty much universal across the majority of, certainly of the richer half of humanity. There is the relationship, or the lack of a distinction in many cases between applied and fundamental research. If you do fundamental research in things like physics, that is typically very different from the application of physical principles to something. Computing, again, that's often not very clear. So the translation from fundamental insights into applications can happen very quickly. Then there's this concept of logical malleability. This is a concept that was put forward by Jim Moore about 30 years ago, 35 years ago. And the idea here is that while you can never fully predict the use of a technology, no matter what technology, it can always be used for something else. This is even more so for information technology because it is built as a multi-purpose technology. So when you build a new piece of hardware, when you build a new compiler, whatever it might be, you know that you have no idea what it's going to be used for. Now that's different from, again, building a bridge. Now you can use bridges for other purposes than just crossing a piece of water, but it's fairly confined. And so computing, the problem is even the possibility of predicting what it might be used for is very limited. And then the final one is what's called the problem of many hands. that you build on what other people have done, and you have no idea what they've done, and you have no way of even getting in contact with them. So if you program something in C, and you use a library in C, that somebody has put something in there, it probably works, but you have no idea who it was, and you don't know what the bugs are in that, and you have pretty much no way of finding out. And that, of course, escalates up to the top if you have a complicated system. If you use your Facebook on your mobile, for example, then there are so many pathways through that and so many contributions that it's utterly impossible to figure out who's done what. And if something goes wrong, whose fault it is. Right. So these are some examples of why ethics, why the question of right and wrong is of importance and specifically difficult in the area of computing. Now, this is the end of my general theoretical introduction. And what I'll do for the rest of my talk is talk you through a few examples of stuff that I have done in recent projects or ongoing projects to get a handle on how do we deal with these questions, how do we understand what ethical concerns are, and how do we address them? So what can be done about them? The first one is comes out of a quick introduction to those projects. So Sherpa and Sienna, all three are EU projects. Sherpa and Sienna were projects that ran from 2018 to 2021. So they were sort of sister projects with a lot of overlap. I coordinated the Sherpa project, and Philip Bray from Twente University in Holland coordinated the Sienna project. But Philip was also a member of the Sherpa project, so there was a lot of overlap between those. And then the Human Brain Project is a future and emerging technologies project, a flagship project. So this is one of the three very big funded EU projects. They ran or still run for 10 years. They had a significant amount of funding. So the Human Brain Project had a core funding of somewhere around 450 million euros. To be spent over 10 years. We have about 100 to 120 partner organizations, so it's huge. And what it does is it brings together ICT and neuroscience. So the current aim is the development of an infrastructure for neuroscience. Sherpa and Sienna, on the other hand, were specifically targeted at identifying ethical issues, human rights issues, social concerns of emerging technologies. Sherpa focused exclusively on what we call smart information systems. And so the term didn't stick. So these days I tend to say AI. So it's typically machine learning driven systems that have some sort of application in the world. And Sienna had a slightly broader remit. It looked at 3 different technologies, but also one of those was AI. Right. So what I'll talk about in those 2 examples of Sienna and Sherpa is really thinking about how we identify and how we deal with, in particular, ethical issues of AI. So I start with Sienna. So this is an attempt to build a methodology. And again, this might be of interest to computer scientists who typically use methodologies in order to develop their systems. And the idea here is to develop a methodology that is applicable and can be integrated into existing development methodologies in computer science, with a specific view to ensuring that ethical issues are looked after. So the problem, and this work comes from the Twente colleagues. It comes predominantly from the University of Twente and the ethics of technology group there. What's important and relevant to note is that the outcome of this work that I'm now going to present has actually been adopted by the European Commission, and it is one of the recommendations that they provide to deal with the ethical issues of AI. So if any of you have written an EU proposal in the Horizon Europe framework program, you will have seen that there is an ethics guidance document, which has been there for many years, but at the start of Horizon Europe, they added AI as an ethical concern. So if you now write a proposal and that proposal contains AI, you develop AI, you use AI, whatever it might be, you have to demonstrate to the Commission that you have a way of addressing possible issues arising from the use of AI. And one of the ways you can do that is to adopt this methodology, which I'm now going to, well, I'm just going to give you a very brief overview of it, but there is more detailed guidance on how you actually implement it and put it in practice. Right? So this actually has had some significant impact in that it has become part of the Horizon Europe policy. Right. So what's it about? It's about the issues that AI can raise, and typically what happens is that, and that's technology ethics in general, somebody builds a technology, it does something terrible, and then we all scratch our heads and think about, well, what happened here? Why did it happen? And the idea here is that instead of waiting until everything has gone pear-shaped, we want to intervene early on. So we want to think about what are ethical issues at the point of developing, creating, modeling, putting things together. So the idea here is to come up with some requirements that will help you or help a developer create an AI that is less likely to create ethical problems. Now, if you're interested, if you've followed the ethics of AI debate, it's huge. Right? There's a load of stuff happening, including new journals, new conference series, all sorts of stuff, and a lot of policy at this point. AI is a buzzword, it's a hype, and that has translated over into ethics of AI, but it also has translated over into a lot of funding. So governments the world over commit huge amounts of money to AI development. At the same time, they realize that this may be problematic, and they have started to think about how can we ensure that AI is actually beneficial. And you see that there are lots of different initiatives, from the IEEE to World Economic Forum to various governments, and also to industry. A relatively recent one is the US Bill of Rights for AI, I think 2 weeks ago. Biden launched it, so that's pretty brand new. But of course, in the US also, there's been detailed work going on for years. Right, if you're interested, you may want to look up NIST, the National Institute for Science, for Standards and Technology, I think. They're currently consulting on an AI impact assessment process, which I think is actually quite nicely done. Anyway, point is, there's a lot of stuff happening. The reason why we're facing this set of problems around AI is that, or arguably one reason for that is the fact that not enough consideration is given to the consequences of the use of AI at an early phase when it's easy to intervene. And the solution, the suggestion on how to deal with that is something called ethics by design. And this follows on from lots of other by designs. So you may be aware of privacy by design, these days called data protection by design. You have security by design, you have everything by design, and the principle is always the same. You try to think about what can go wrong later at an early stage in order to be able to catch it. So, and here the idea is to think about ethics at an early stage and bring it into the design process. Now, this is also linked to what's often called value-sensitive design. So the same idea. So you want to think about what values should be expressed through technology. And value-sensitive design was, I think the term was coined about 20 years ago, where it's based on the same principle. So you look at what values do you want to have realized, and then you try to make sure that in the design process you consider them and try to bake them in if possible. Now, I will come to limitations of this approach at some point. Right, so if you want to do that, the first question is, what values do you want to use? And that then comes back to my earlier question, what is ethics? And somebody responded, well, it's up to you to say what morality is. Well, now if I can do whatever I want, then ethics becomes completely relative. And then it sort of loses a key characteristic of ethics, namely that it is applicable across people. And we could discuss, if you want to, we can discuss to what degree ethics actually is relative or is not relative. If you want to build it into design, then it's no good to just say my values. So my values may be X, Y, and Z and build them in the technology, but that doesn't help anybody. So it's got to be broader, it's got to be more universally applicable and obligatory. So the question then is, what do we use for that? So you have some principles for Europeans, for example, you have the European Charter of Fundamental Rights, you have the UN Charter of Human Rights, and a lot of the work at the moment around ethics of AI looks at what are those principles that we agree on, and which ones of those are most likely to be violated by AI, and then you pick those and try to bring them in. The values you see here on the right, these are the values that were chosen and developed in more detail by the ethics by design methodology we're looking at here. And they are heavily influenced by the high-level expert group on AI that the European Commission put together. So this was a group of about 50 eminent individuals who came together and started to think about what are the ethical concerns, and they've developed a framework which was based on and included these values. And so what Philip Ray and his colleagues have done here is they've tried to turn these values into what they call ethical requisites. And these are really requirements for the system's development. So what they've done then is to think about, well, how can you actually do this? How, at what point in the development cycle can you integrate these values? And what you see here is sort of an attempt, well, I think it looks a bit like a waterfall model from where you do from systems analysis all the way to coding and evaluation. And they've thought about where in these different steps could you think about what sort of value. So you have the objectives, requirements, general design, data collection, full design, and testing. And they have come up with the methodology where you can think through at which stages you could consider these values. Now, I think I'll leave it here. They have done this in a lot more detail than the bit that I can tell you here. The main message is it's an attempt to think through ethical issues early and then think through how you can integrate this reflection, these considerations, into the design of the technology itself. So that's one way of thinking about or trying to address ethical issues of AI. This is my second example. This comes from the Sherpa project. And what we've tried to do there is identify ways of thinking about ethical issues that can help to ensure that AI can produce or be positive and supportive of human flourishing. Now, human flourishing is, we use that term because it is a well-established ethical term. This comes from traditional virtue ethics, so you can trace it back all the way to Plato and Aristotle. And so we try to think about how can human flourishing be supported by AI. And this was based on the assumption or on the insight that AI is not just a piece of technology. So it's not a bit of machine learning sitting on its own somewhere on a shelf, but AI is typically something that's integrated into broader systems, into socio-technical systems, and often societal level systems. So the question then is, how can you look at these ecosystems? And we use the metaphor of the ecosystem because that's widely used in AI. So how can you use this metaphor to think about what you need to do in order to ensure that AI supports human flourishing? So that was the question. And in order to answer it, we first wanted to look at what are characteristics of ecosystems that we would need to consider. And a lot of the what I'm talking about now comes from the innovation ecosystems literature. So this is innovation studies. If you have colleagues in business schools, you may have people who are interested in this sort of stuff. So what are the characteristics of ecosystems? Firstly, they have unclear boundaries. It's not always obvious who's in, who's out, what's part of the ecosystem, what is not part of the ecosystem. They tend to be open, so members of an ecosystem can disappear, they can leave, new members can come in. So systems are not hermetically sealed and bound. They change over time, and the question is why they change. And one of the explanations that comes from biological ecosystems, but that's also very attractive to the innovation ecosystems literature, is this idea of evolution. So things evolve, and that leads to dynamics in the system, which makes the system change over time. Now, the members of the ecosystem or the inhabitants of the ecosystems, they don't just evolve on their own, but they actually co-evolve. They can learn from each other, and they're interdependent. That means on occasion they compete, on occasion they just collaborate, but they're never completely isolated. They always do whatever they do in conjunction with the other members. So the relationship between actors is typically complex, and that also means that it's typically difficult, if not impossible, to predict how a particular intervention in the ecosystem is going to play out on the whole systems level. So these are some of the characteristics of ecosystems. And then the question is, how do those translate into requirements for intervention? So what can you do, should you do, in order to steer an ecosystem in a particular direction, in our direction, or in our case, in the direction of human flourishing? How can you do that, and what's required in order for that to be successful? So on the one hand, we think that this requires a clear delimitation of the ecosystem. So where exactly are the boundaries? And these can be geographical boundaries, so you can have an AI ecosystem in the UK or in Germany or in Europe. You need to say where are the boundaries. But there are also other types of boundaries. So what sort of technology are you looking at? What sort of concepts are behind this? So you need to, in order to influence the ecosystem of a particular AI ecosystem, you need to understand what exactly it is, what's in and without out. And there's an interesting question of how you draw those boundaries. Then within the ecosystem, in order for this to act on the world and to promote human flourishing, there has to be knowledge that is available. And that includes technical knowledge, that also includes conceptual knowledge, such as what do we mean by AI, what do we mean by stakeholder engagement, procedural knowledge in terms of what can you do, what can you expect in terms of outcomes of a particular activity. And this knowledge base needs to be updated and maintained. So there has to be capacity building within the ecosystem. And then finally, there are questions around the governance of an ecosystem. According to everything I've said so far, now you can't just force an ecosystem down a particular road. Rather, you have to have an adaptive governance structure that's flexible, that's able to learn, that's able to reflect on what's happening. And you have to have what I've called meta responsibility, i.e. you have to be able to work with existing responsibilities that already are present in the ecosystem. So an ecosystem doesn't start from scratch. It always develops in an existing environment, and that existing environment will include things like responsibilities. So to give an example, as a software engineer, you have responsibility for your employer, but you may also have responsibilities for your professional body and your professional standing. At the same time, you're a human being who has responsibility for the family and so on. So we all have loads of responsibilities that exist, and the ecosystem governance needs to be able to work with those and support them. Right, so what does that mean? These are our recommendations coming out of the Sherpa project. What should be done in order to promote human flourishing through AI? So according to the three requirements that I've just listed, the first one is that there needs to be conceptual clarity. So it needs to be clear what ecosystem we're talking about. On the governance level, we have suggested that there should be a regulatory framework. So this could be legislation, it could be other types of regulation. We're suggesting that because it's an EU project, or it was an EU project, we're suggesting that there should be an agency for AI somewhere on the EU level. And on the organizational level, we're suggesting that there should be somebody, there should be a role in an organization that is responsible for questions of the ethics of AI. And we've called this role the AI ethics officer. And then finally, there are knowledge requirements. So we're suggesting that there should be a baseline for AI impact assessments, so that these should exist, and there should be an understanding of what they are and what they do. We are suggesting that there should be a principle of ethics by design. So this goes back to what I said earlier. This is Philip Bray's work. We're suggesting that there should be training and education facilities. Standardization needs to take consideration or take AI ethics issues seriously. And we've done a specific work stream around security, and we have some suggestion on how that could be implemented in AI. Now, one interesting point of this here is that while these are separate recommendations, and if you look at the Sherpa website, you'll find that all of these have, we have lots more detail on all of those, but you shouldn't take them in isolation, but you should realize that they actually are a package. So there are relationships between them. So the delimitation of the ecosystem, for example, is required to say what the knowledge base contains. Similarly, the knowledge base will inform what we mean in terms of delimitation. The governance structure may incentivize the creation or update of a knowledge base, which again then informs the governance structure. Governance will need to be based on an understanding of what the delimitation actually is. So you have sort of relationships between those different big bubbles. But there are also relationships within those bubbles. So as an example, a regulatory framework could mandate the creation of an ethics, of an agency. It could mandate the existence of an AI ethics officer on an organizational level. Same for ethics by design. In order for ethics by design to work, it might draw on impact assessment. It would probably require somebody to have a certain level of training. It might draw on standardization. It might draw on security insights. And finally, there are also links between those individual recommendations across those bubbles. So an AI ethics officer might, for example, be defined by a certain training pathway that will need to exist. Or a regulatory framework might include an AI impact assessment as part of a requirement for a company. So the point is that this, and this is really the same picture, just looking slightly prettier, is that these things all need to be thought about in conjunction. They come together. So you have those three different big bubbles. Within those bubbles, you have individual recommendations, but you need to look at the package, and only the package as a whole, or not only, but the package as a whole is more likely to lead you to an AI ecosystem that is conducive to human flourishing than if you just pick an individual one. Right, that was Sherpa, and now I will come to my last example of how we can do these things in practice. This is the Human Brain Project, and I see I'm halfway through, so I'll probably expedite this a bit. So the Human Brain Project, as I said, is this very big project. It brings together ICT and neuroscience, and it now works predominantly on the creation of an infrastructure which is going to be called, or it's already called, eBrains. But pretty much exactly a year, at the end of September 2023, the Human Brain Project will stop, and eBrains will be the legacy, the leftover of the Human Brain Project. Now, this is possibly of interest because it shows the breadth of issues that you can encounter when you think about ethics in IT. So this is an attempt to list the dominant ones that we've dealt with in the Human Brain Project over the last 9 years now. And you see that there are some traditional research ethics issues. So we had, for example, animal research, we had human research. There's a lot of data-related questions. That is clearly data protection, but also other types of questions around data governance. There are neuroethical issues here, questions of what is consciousness, how is it defined, how can you measure it with an IT system. But then there are lots of other things like dual use, misuse, use for security purposes, the question of diversity and inclusion within the consortium, but also within the data. There are questions of who owns it, who gets the benefit, commercial exploitation. There are questions around what happens on the societal level because of it. Does society actually support us? Now, do we have a license to operate, as they say? And these days, it's also AI as a specific ethical issue. Now, what we've done in the Human Brain Project is we've tried to develop a program of what we've called responsible research innovation. Well, not just we. This is something that the European Union promoted very heavily in the Horizon 2020 framework program. And we try to put this in practice and try to use that to get us to reflect, to help us to reflect on what those issues are and how they can be addressed. So we've done a lot of activities. So we've done a lot of research around responsible research innovation, including neuroethical reflection, but also foresight. So we've thought about possible consequences. We've engaged with different publics. We've worked with people within the project to develop awareness. We've developed an ethics support program, and we've also developed a capacity development program that will help people who use the eBrains infrastructure to deal with those questions. Now, these are some of the key structures, and these are structures, I would say, for reflexivity. So they force us to think about what we're doing, to think about the ethical issues. We have an ethics advisory board, we have an ombudsperson, we have an ethics rapporteur program. So these are individuals who are within the project who work specifically with the Ethics and Society group on the question of what issues arise in their specific area. We have compliance management, we have various working groups around data governance, dual use, diversity and equal opportunities. And we're also part of the project governance. So there's an ethics director, which is me. And we also have a work package leader on responsible innovation who sits in the Science and Infrastructure Board, which is the key scientific decision-making body of the project. What have we learned from doing this for the last, well, almost 10 years now? We've learned that some things work. So for example, public engagement can actually change the way a project works. We've also seen that compliance issues tend to be dominant, in particular data protection. There may be more interesting questions than the data protection, but data protection always gets a big seat on the table because it's heavily regulated and you get fined if you don't do it. We've learned, well, we suspected before, but we now know that interdisciplinary collaboration is difficult. So working between a social scientist, a philosopher, and a computer scientist runs into all sorts of challenges. We now also know that responsible innovation or responsible research and innovation is a concept that develops. It's not set. There is no simple answer of how you can do it. But a key insight is that working on responsible research and innovation also requires research. So a lot of the ethical issues have something to do with science and are not necessarily obvious. So responsible research and innovation research should be part of the overall research agenda. And as in many cases, it's difficult to prove that it works. So I think this is my last substantive slide. So responsible research and innovation remains a contested concept. Expectation management is important, and that means we shouldn't promise that we can solve all the problems of the world, because we can't. But we can certainly try to understand them better, and I think that really is the key here. Ethics is not about solving the issues. Ethics is about being aware and remaining in a conversation about what the issues are. So uncertainty, conflict, they will remain. We are not going to get rid of them, but we may be able to deal with them better if we understand that responsible research and innovation is not a solution, but a process. And that process needs to co-involve with the science. So it's not a set thing where I can tell you now, this is how you do it, but rather it has to be part of the science itself. I'll skip this one and just give you a couple of references. So this is a paper published a couple of weeks ago where we tested the Altai guidelines, the assessment list for trustworthy AI, in the live environment, in the Human Brain Project. So we asked a few hundred scientists around their use of AI. And if you're interested in the outcomes, you can read the paper. And there are a bunch of resources around various aspects of, in particular, the Human Brain Project work. And finally, if you find any of this interesting, on the left, there's a book which you can download for free. It's an open access book where I developed this idea of the ecosystem perspective in more detail. And on the right, you see the detailed description of the ethics by design, which was my first example. And I think with that, I will shut up and stop sharing, and you can ask me stuff.
Many, many, many thanks for that, Bernd.